calculator, you have y equals x squared in your calculator. All right. Notice I have the grid lines on my screen right here. By the way, this whole thing right here is called the Cartesian plane. So your vocabulary, when it says the Cartesian plane, that's referring to the coordinate grid. So if you see the word Cartesian plane, somebody asks you to draw a Cartesian plane. Basically, it says draw an x-axis and a y-axis. That's what the Cartesian plane is. All right. Also referred to, more commonly referred to as a what? Yeah, coordinate grid. So that's why I turned the grid lines on for us. Okay. Now, it's always helpful to know your way around the grid. All right. So we have different quadrants. What do we call this quadrant right here?
2.
No. 1. This is quadrant 1 right here. This top right-hand corner is quadrant 1. By the way, in quadrant 1, all of your x values and all of your y values will be positive. When you first started graphing as a little kid, you probably just stayed in quadrant 1. So a teacher would give you a point right here and say, give me the ordered pair. And you're like, 1, 2, 3. That's 3, 2. They're like, yay. All right, but then what happened? They gave you structure to give you what? Not just positives, but negatives. So, oops, that sounds so negative. All right, so we have, over here we have quadrant 2. All right, and the x values are negative, but the y values are positive. So we kind of be taking notes. This is kind of helping you. We're defining the quadrants just by drawing pictures.
So the y is positive?
Yes, the y's are positive.
Okay, number 4.
And quadrant 2.
There. Number 1,
Both positive. Both positive. Then we have quadrant 3. Now, I'll tell you what. This is where teenagers live. Okay? Teenagers live in quadrant number 3. Because all the x values are negative and all the y values are negative. There's just a whole bunch of negativity going on in quadrant 3. This is where I think teenagers live. Alright? If we lived in a 2-dimensional world, this is where you all camp out. Alright? I camp out in quadrant 1. I'm pretty positive guy. You guys camp out in quadrant 3 because you like to do it. Alright? Alright? Then we have quadrant 4. Right? Positive x and negative y. So you got to know where you are on the coordinate grid. Okay? So this is a function. We already know it goes up like this on both sides. Now, how do we know if something is a function if all we see is a graph? What you're going to use is what's called the vertical line test. We're going to cover this concept right now, known as the vertical line test. So I am going to make a vertical line. It's going to be red. So right here, if I put a vertical line right here, or I put a vertical line right, you don't do all of these, okay? You just do one of them if you want. Make sure it's vertical. No matter where I put this vertical line, how many places does it literally touch the graph? Just one. Right here. It touches it right here, 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 here. It does not touch it in more than one place. So this is called the vertical line test. So right here, underneath vertical line test, you could write a graph is a function. You want to write like a definition of vertical line. If a vertical line only touches the graph once. Not twice, but once. So a vertical line can only touch it in one place. It cannot touch it in more than one place. Because that means that the vertical line, each x value still only has one y value. Now I'm going to show you something that is not a function, and hopefully by doing the vertical line test, it will make a little bit more sense. So I'm going to pause it real quick, let you guys write this down. So what I'm going to do real quick is I'm going to go ahead and go to the screen real quick. I'm going to hit y equals. I'm going to clear it out. All right? Let's try something kind of cool in the program. Let's see here. I'm going to go second draw. All right? And I'm going to go down to number 9. And I'm going to draw a circle. Let's see if this works. I think I'm going to go 2, 3, 3. Let's see if this works. I'm totally wrong. did there is I said, have the center at 2, 3. Watch, I'm going to go zoom. I probably need to, let me go back here real quick. Let me change the radius here. I'm going to go up here. I said, I want the center to be at 2, 3, and I want the radius to be 3. So that was kind of a big radius. So let's go down here and say, let the radius be just 1. Oh, hold on. Let's try this again. Enter. There we go. Now we can see it. Okay? All right? Hey, stop looking at me. All right, so we got an eyeball right there, kind of. Pokeball. All right, we have a Pokeball. All right, so you guys can kind of imagine that we have it's kind of going like that. I know it's not a perfect circle. All right, hold on. Let me see here. Select trace. Can I trace anything? I think I can trace. Oh well. So I can zoom. I'm gonna do zoom standard. Zoom 6. I don't like that. That's not right. That was like an oval. All right. So hold on. We're just gonna do zoom 4, and we're just gonna do the one circle up here. All right. Let's deal with that circle. So understand, zoom 4 allows things to have a 1-to-1 ratio. Zoom 6 does not allow things to have a 1-to-1 ratio. Now, if I put a point right here and a point right there, and I do a vertical line test, and I go straight through those 2 points, eventually I'll go straight. What's the ordered pair for this point right here? That's at a what? That's at a 2, 4. What's the ordered pair for this point right here? 2, 2. So if I gave you guys an ordered pair, all right? If I said, oh, here's a function, everybody. Here's your x and y. I have a 2, 2 and a 2, 4. Automatically, you can look at the table and go, we've got problems in this mood because you have the same x value and 2 different y values. By the way, does this pass the vertical line test? No. Because it touches it not just at one point, it touches it at 2 places. So the vertical line test, if it touches it more than once, it lets you know this is not a function. So let me tell you something, everybody. What am I telling you about a circle? A circle is what? Not a function. And if you wanted to justify your answer, what could you draw on your paper to justify your answer? No, we're going to a vertical line saying, it touches it at 2 points. Okay? So here we go. We're going to do a quick little graph and see if you guys can tell me, is this a function or not a function? All right? So here we go. We're going to the graph. We're going to draw a quick little graph. It won't take long. All right, here we go. Is that a function or not a function? I would agree. That's a function. Because if you did a vertical line test, by the way, a lot of times I have like a meter stick, and I'll go by it. I know you can't see this on the computer screen, but you just kind of like go across it like that. So test it by taking a vertical line and making sure that no matter where you put it, it only touches it at one place. Okay? All right. Let's see here. How about this? Right? Would that be a function? Why not? Because if you do a vertical line test, it doesn't touch it just once or twice. It actually touches it 3 times. So remember, would you agree, whatever this x value is right here, like close to a -1 right there, that's the same, that's the same, that's the same, but they have 3 different what? 3 different y values for the same x value. Okay? So that's what you're doing. Okay? Now let's look at your vocabulary. Somebody not covered anything. Oh wait, one more thing. Everybody, we got to talk about this. We got to talk about continuous versus discrete. Continuous versus discrete. So what I want you guys to do on your paper right now, make a quick little grid on your paper. Cartesian plane. Doesn't have to be a lot. All right, and follow along. All right, so if I draw something like this, this is continuous. It just keeps going forever. All the points are connected. All right, it's continuing. This is considered to be not just continuous, but you could call this a continuous function because it also passes the vertical line test. Okay, but Garrett, if I went like this does not pass the vertical line test, but is it continuous? It is continuous, so you could call this a continuous relation. So here's a continuous function, continuous relation. All right? You're used to seeing functions that are like a line is a continuous function. Okay? A parabola is a continuous function. Okay? So these are examples of continuous function. This is just a relation. Now discrete's a little bit different. Discrete are points. So if I have points going up like this, everybody, this right here, these set of ordered pairs right here, you could call this a discrete function. This is a discrete function. Each of these ordered pairs, as a set, each x value has only one y value. So that's a discrete function. This is where students sometimes get confused. What is a discrete relation? So watch this. If I have an ordered pair right here, and I have another ordered pair right here, so far so good. But then if I jump up and I put one directly above another one, and then I continue to go. So right now, if I had just these, it'd be fine, but these two have the same what? They have the same x value. So this right here is at a 1, negative 1. This one's at, not 1, 2, 2, negative 1, and this one is at a 2, 1. They share the same x value but have different y values, so we call this, it is discrete because it's not continuous. We call this a discrete relation. Discrete because they're just points being plotted. Okay? So understand, if I ask you to tell me whether something is continuous or discrete, I also want you to tell me, is it what? A discrete function or a discrete relation? Is it a continuous function or is it a continuous relation? So be specific in your identification of what's going on in a graph. That's what I'm asking. Okay? We're going to be working on we're going to be working on this tomorrow. Oh, one last thing. This is literally the last thing we're going to do. So don't put it away. Hold on. We've got to make a little table real quick. We've got to put vocabulary words in this table. Won't take long. All right? I'm going to call this table X. I'm going to call this part f of x, also known as y. Refer to your x's as your independent variables. Refer to f of x as your dependent variable. Your x, the set of all of your x values is considered to be the domain. The set of all of your y values is considered to be the range. X is your input. Y is your output. These vocabulary words, you need to know which goes, where they go with. Whatever you want to say. If you're talking about x, you're talking about the domain is the set of all of your x values. One x value by itself is the independent variable. Okay? So make sure you know these words go with x, these words go with y. Okay? Y'all have a good day.